The mystery of Mars's moons points to a potential ring system like Saturn. 4 fast radio bursts pique curiosity. They're not coming from a supermassive black hole. And Proxima Centauri b confirmed 4 years since discovery and 4-ish light years away. It's Saturday, June 13, 2020. I'm Matt Miller. Good morning. Welcome to Talkin Science UNCUT, produced live all across Trekzone's socials. Let's talk that science.
Across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is Talking Science with Dr. Brad Tucker and Matt Miller.
And what an eclectic mix of stories we have for you today on Talking Science. Dr. Brad Tucker, happy Tuesday.
How's it going?
Really good, really good. When I got your email this morning with the stories that we're going to cover, I was very excited. SpaceX is out of the news. China's rocket troubles are out of our news. Everything's just going back to normal, it sort of seems.
It sort of seems, yeah. Deceptions are deceiving, but you know, it's that's the way it goes, and yeah, there's still a lot to get through.
There certainly is. And another thing in our opener today, I have dropped our count up clock of how long it's been since coronavirus has locked us down at day 79. I think everyone gets the point that it's the new normal.
Yeah, and look, you know, lockdown is slowly changing here in Australia and getting less lockdowny. So as you said, yeah, that is our new normal now. We'll adapt.
We certainly will. And of course, you can find Brad on socials, on Facebook, Dr. Brad Tucker, on Twitter, btucker22. Trekzone's all over socials as well. Just search for Trekzone. Brad, let us dive into the headlines.
Talking Science headlines.
Northrop Grumman has been awarded another contract for Artemis, this time in regards to the Halo module.
Yeah, so, you know, this is kind of going to be one of the main crew quarters, and, you know, the gateway's still moving on. They're actively doing and assigning all the components, and they still want to hit a 2022-ish launch date with SLS and Orion, and I think what we'll see is the delay on anything will be SLS rather than the actual capsules and components being built. But you know, it's reality and it's moving ahead, which is exciting to see.
Starlink has another launch and some more technology to try and limit its reflectivity.
Yeah, I mean, it's not the interest here, in my opinion, is the Starlink, but they're deploying the first of what they're calling the visors, where it's essentially a shield or visor that reflects the sunlight away from the Earth. So, you know, the reason we complain about satellites is sunlight bounces off the satellite and then bounces down to Earth. And you have a limited angle between, you know, after sunset, before sunrise, where the angles can work as you're passing over. If you design a shield that reflects it away at those times, so the light, instead of bouncing down, bounces up, or, you know, just away, it will significantly darken and potentially eliminate a lot of the problems that we're seeing with the Starlink satellites, and also without A, anything being costly, or B, anything compromising the mechanics and engineering of the craft. You know, they've talked about painting it black, but thermal properties aren't great for painting things in black. So this, and in fact, Elon Musk even said when he announced this at a conference with astronomers, you know, hey, this kind of just hit us as a very simple idea. And everyone's like, well, yeah, it kind of is. And if it works, great. You know, we all want to see it succeed and find that middle ground, and we hope this works.
Do you think it will?
In principle, it sounds right, but you know, it nothing is ever straightforward. You know, obviously you worry about if it works, then components failing, you know, how well that works. But I think this has more promise than other iterations. And if this works, maybe this is actually not just for Starlink, but for all future satellites, because it's not just them, it's all the ones that go up. This could be a big benefit, but also could easily slide into helping limit the trackability of satellites. That would be actually quite useful for defense.
Starlink launches more satellites again. They promise to be inconspicuous again. They've got some more technology on board to help try and solve this problem of destroying people's observations of the night sky. And as you could see in those images there, it really does, like you talk about these little satellites and how bright could they actually be. But in those in that video that we had, that we showed you there, it just goes to show that when you're trying to find these really faint objects, having even a little bright object just blows everything out of the water. And of course, Northrop Grumman, they're getting the contract for the Halo module of the Gateway Station, which is going to be in lunar orbit around the middle of the decade, which is going to be very, very cool. G'day everyone, and welcome to Talkin Science Uncut, produced live right here on Trekzone's socials, which of course include Facebook, Twitter, Instagram, YouTube, Tumblr as well. Like, follow and subscribe to us on all of those platforms to get in the know of everything that's happening at Australia's unofficial home of Star Trek. We're now more than Star Trek though, with the Orville episodes and Babylon 5 coming soon, which is going to be very exciting. Alrighty, well let's keep going with this show. The mystery of Mars's moons is our first story of the week. This is really fascinating. Potentially, in the next 50 million years, Mars's moons could become Mars's ring system. Dr. Brad Tucker and I discuss in this Talkin Science Story of the Week.
Talking Science Stories of the Week.
Alrighty, Brad, let's get into our stories of the week. Like I said, it's an eclectic mix of this week, kicking off with our nearest neighbour, or our other nearest neighbour, because the moon technically is our nearest neighbour. Mars used to have a ring system just like Saturn, apparently.
Yeah, and this has been something that is quite interesting. You know, when we look at Saturn, you know, it's famous for its rings, and, you know, that's what distinguishes it. When we look at Mars, we know that two of its moons, Phobos and Deimos, its two moons, rather, they're tiny. You know, we're talking about things that are 20-ish kilometers wide, you know, smaller than a city. And at the same time, they're slowly falling towards the planet. So the gravity's pulling them in. They're slowly spiraling and spiraling and spiraling, getting closer. We think that at some point, gravity would rip it apart, form a ring. Now, that's always been the theory of what's going to happen in the future and, you know, what's going to happen in 20 million years. The question is, how did those moons arise? And it appears from a recent study that they think that maybe it's a cyclical process, that as the moons go in, they fall, they form a ring system. That ring system eventually comes back together to form moons, which then spiral towards the planet and repeat. So these moons may have started out as a ring system altogether.
What I find fascinating is that Phobos and Deimos were both discovered in 1877, but here we are almost 150 years later, still learning about or making new discoveries about these two little rocky objects orbiting Mars.
Yeah, look, you know, these moons have been around for, as you said, for ages. But they've always just been different. They're very different than our moon. They're very different than the moons of Jupiter and Saturn and all the other, you know, the big ones. Those make sense. Those moons, Jupiter and Saturn, are in fairly stable orbits. Mars has always just been different. And, you know, we've talked about this with our moon. Our moon is drifting away, getting further. Why are these moons getting closer to the planet? It's a very interesting thing that has remained a mystery for ages. And, you know, maybe this explains it. And also just how rings play into moon formation.
Interestingly, Deimos is tilted by 2 degrees in its orbit compared to Phobos.
Yeah, that's right. And this is one of the things that's maybe led to that there is this discrepancy, is that when they collided, it has a little bit of a tilt and it's coming in, and the migration is relative to its size and, you know, angle. You know, it's always been thought these were captured asteroids. These look very different. You know, Mars is so close to the asteroid belt, it kind of makes sense. But why is it only 2 and why is it these 2? So it could be a very clear discovery. And then when we think about the context of other ring systems, you know, does this happen? Do the ring systems break apart, form moons, and eventually, you know, form new moons if those moons break apart? You know, is it just a one-off process? Is it a repeating process? Because the 4 gas giants all have ring systems.
It is very interesting, and it's a curiosity as well, because what's the sort of thought process on ring planets? I know in sci-fi movies and TV shows, many planets have ring systems. I guess it's an easy way to denote a science fiction planet or an alien planet. Is the sort of thought process in the real world that only gas giants could have rings?
No, when we go back to it, rings and things that form in disks, it's just the natural process of forming things in space. We talked about with the baby star being born, it's a swirling disk of gas. Galaxies are disks. Everything likes to form in a disk. That's how physics and angular momentum simply works. So the question is, when does it stop? I guess, and that's the real question. When does stuff stop forming in a disk, in a ring, and just always coalesce into a ball planet? And it probably was the case that the moon was actually a ring around the Earth. When something collided into the Earth, all that rock came out, formed the moon. That probably formed a ring before it formed the moon. So we think probably ring systems are a natural process and a very common process. So it then really starts to question, why is Saturn's ring so prominent? Why is it so big? Why is there so many? Because when we look at Jupiter and Uranus and Neptune, they're fairly small ring systems. They're hard to see, but they're there. So, all right, that kind of makes sense. But what is it about Saturn? And then what is the case about Mars? So I think, people are starting to realize ring systems give a lot of clues into the nature of how that planet and what the stuff was around to form that planet at that time.
This study that has come out poses a potential problem for the Martian colony within 50 million years. So kind of not really a problem, but it sounds good. Phobos it's losing its height and will quite possibly very soon get ripped apart by Mars.
That's right, and it will form a new ring system. And the question is, what happens to the people on the planet? Obviously, probably minimal, but they would have a higher increase of meteor activity. The atmosphere of Mars is a lot weaker. Therefore, you'll get a lot more crater impacts. And then I think the question is, if this process really happens, that it breaks apart, forms a ring, comes together, forms moons, breaks apart, at some point you will slowly lose material and energy in that process. And at some point you would think that it would stop altogether and there would just be not enough stuff and the moon systems would completely disappear.
Well, how amazing would that be to be on the Martian colony looking up at this ring system in orbit of the planet? I think that would be really, really cool. And it's something that we see in science fiction films and TV shows all the time. Well, not all the time, but sometimes. Saturn's got it. Why can't Mars? I think it'd be really fascinating to see. Maybe we could accelerate that 50 million year timeline. I'm not sure. But anyway, let's keep going with today's Talkin Science Uncut. Dr. Brad Tucker and I, in our second story of the week, are talking about fast radio bursts. These things that astronomers thought came from supermassive black holes. Turns out, maybe not. Dr. Brad with the details on this Talkin Science Story of the Week.
Talking Science Stories of the Week.
We featured this last week as well, Australian astronomers leading the world in scientific research. Another discovery is fast radio bursts. And we've talked about these a little bit, I think, in the past. Glenn Nagel from the Canberra Deep Space Communication Complex will be on Monday next week to talk about Parkes' contribution to FRB discoveries. But there are 4 of these little signals that are throwing what scientists thought they knew in the trash can.
Yeah, we've definitely talked a lot about this, and in fact, last week we're trying to find the missing matter. And so the question is, where do these fast radio bursts come from? How are they created? And there's lots of theories that have come about, and one was they're somehow involving a supermassive black hole, either star orbiting around it, material falling into it, and as it gets near the black hole, the gravity of the black hole rips it apart, spits it out, releases a burst of energy, and it would be fairly quick. However, this recent study was able to pinpoint the locations of at least 4 of them, and all 4 did not occur in the center of the galaxy. So supermassive black holes essentially are always in the center of the galaxies. That's where they reside. That's how the black hole in the galaxy comes to form. So if it's coming from not dead the center where the black hole is, then it just doesn't involve a supermassive black hole, because even if you'd say maybe there's another black hole in there, well, there are other black holes. The supermassive black hole, if there would be another big one, would have already coalesced in the middle, unless for some reason you happen to see its emerging galaxy system, two galaxies colliding. But then you would see two separate galaxies. So it kind of rules out one of the more used or potential explanations of fast radio bursts.
Now, while it's estimated that several thousand of these bursts happen per day across the entire sky, the fact that they're very brief, lasting only several milliseconds, it is an incredible achievement to find these things, to tune in and listen to these things across the sky.
Yeah, you're looking for something that ultimately sounds like a glitch for, not even a fraction of a second, and you have no idea where it's happening, where it is, the exact frequencies, it is beyond trying to find a needle in a haystack. It's like if you're trying to find a needle on the planet Earth and, you were blindfolded and then told to go to Mars to look for it. It is that hopeless almost to try and find it. Yet they do because of the instruments they have built. And it's very successful instrument at trying to find this. And so that's kind of been one of the successes, not only finding more of them, but by finding more of them earlier on, getting a lot of that extra information to try and understand some of the nature of what's going on here.
The most famous fast radio burst is FRB 121102, and it's unusual because it's been detected a few hundred times, I'm ready for my pun here, Brad, since it first burst onto the scene in 2014.
That's right. It's a repeating burst. And so people are starting to think, well, maybe there's two different classes of these, the ones that repeat and the ones that do single go-off events. And still, either way, by pinpointing that it's not in the center of a galaxy, it does show that it's probably not a supermassive black hole. Now, something we talked about a couple of months ago, there was a strong periodicity. So, there was an orbit to it. And it kind of happened, there was a pattern that happened with this repeating one, at least, on the scale of every so often days that they were able to detect. And that gave a clue that maybe involved two objects. When two things spin around, they have an orbit, they spin around at a very regular time. Think of our year or think of the moon, anything like that. So that would involve potentially a smaller black hole. So it even gives a little bit stronger evidence to that scenario involving two objects orbiting around, because these things, at least the ones they've discovered, are not occurring where we think the supermassive black holes are.
And given that these fast radio bursts are coming from so far away, is this sort of our indications of the early universe?
So these are occurring relatively far, but still nowhere near as far as the early universe. They're occurring far away, but that would still be kind of in the middle of the universe. What it's telling us, at the very least, is that in the activity of the middle age of the universe, with these things that are whatever they are and whatever they're doing, there's a lot of activity. So it has to be something that has produced enough stuff, stars, black holes, whatever, to be abundant, to be able to be found. But also, as with last week, because they occur so far away, if you can find a way of using them to measure the things in between you, you can get a good understanding of the stuff that we can't see. And that was kind of one of the cool things of trying to find this missing matter, as we covered last week. Just as we use supernova, stars that explode in our visual, to measure how fast the universe is growing, or we can use AGN and the light coming from black holes to measure the size of the black hole. By seeing something big and powerful over different distances gives you a real good scale of just measuring what's in between you and it, which is trying to measure properties of the universe. So really great secondary use of these objects.
Well, it's an analysis of the science that goes into astronomy. Some of those things really go over my head, but Dr. Brad does a fantastic job of explaining it so everyone can understand. Glenn Nagel from the Canberra Deep Space Communication Complex at Tidbinbilla down in the nation's capital is with me on the show on Monday, and he actually talks about Parkes's involvement in the discoveries of fast radio bursts. So look out for that one. The video is available now. The video is not available now, but the watch page is available now. It's set to premiere at 8:30 on Monday morning, Australian Eastern Standard Time. You can jump over to the video page now and set your reminder so that you can get notified when we premiere that video on Monday to compensate for whatever time zone it is you are in. Well, you are watching Talkin Science Uncut, produced live across Trekzone's socials. I'm Matt Miller. Thanks so much for your company. Those socials include Facebook with the wrap-up, Twitter with the latest, Tumblr with the posts, Instagram reliving Star Trek Babylon 5 coming soon, and the Orville episodes. So get across all of those socials, like, follow and subscribe. Leave a comment here on this video on YouTube. Give us a thumbs up. If you didn't like this content, well, the other button seems to work just as well. But if you're going to press that button, leave a comment. Tell me why you're leaving a thumbs down. We'll change. Maybe we'll change. Depends on what you say. Of course, I can't change me. So you'll just have to deal with me. But there you go. That's if you want to use that other button. If you don't, give us a thumbs up. That'd be absolutely fantastic on YouTube. And as I said, like, follow and subscribe to Trekzone on all the social medias. And what about Brad as well? Dr. Brad Tucker on Facebook and btucker22 on Twitter. Alrighty, well, it's time for our last story of the week. We're talking about exoplanets again. Proxima B in the Proxima Centauri system. It's about 4 light years away from Earth. It's the closest planetary system to our own. And it's been confirmed. Proxima B has been confirmed 4 years after discovery. Dr. Brad and I discuss in our final Talkin Science Story of the Week.
Talking Science Stories of the Week.
Well, from a few billion light years away to just a handful, Brad, astronomers have confirmed the size and generally that it's there. Proxima B, our closest exoplanet.
Yeah, and this is something that happened back in 2016, the announcement that there was an exoplanet around Proxima Centauri, the third star of the Alpha Centauri system, that system that's only 4.2 light years away. And people believed that there was an exoplanet, but you, A, always want confirmation, but B, a better measurement to actually measure the properties of it. And this new instrument, Espresso, which we've talked about in other cases, it was used for discovering the nearest black hole, as we talked about a few weeks ago, was able to pinpoint the exact size of this exoplanet, it being 1.17 times the mass of our Earth. So pretty similar in terms of size. It's actually closer in size to us than Mars is.
Having said it's pretty close in size, it's not. It's nowhere near close in terms of its orbit around the star. It's going around pretty quick, about every 11.2 Earth days.
It is. It's a very fast orbit, and this is kind of one of the interesting things that we start to see is we can see the mass of the planet or the size, but then the question is, what are the other properties like? So it's orbiting a red dwarf star. So this is a star much cooler than our own sun. So that means by orbiting close, it's not as saying, you can imagine Mercury orbits our sun every 88 days. So this is much closer than Mercury. You would say, oh, that's really hot, but the star is so much smaller and cooler that temperature range then shrinks, and also the habitability range shrink, and the habitable zone shrinks. So, it moves proportionately. It was always believed to be something we call tidally locked, and that is one side is stuck facing the star. It's the same thing as our moon. There's always one side that faces us. So we only see one side of the moon. Not that it's a dark side or a light side. There's just one side that we can see that sometimes gets light and dark. And so if you have a planet like that, you always have one side in daytime and one side in nighttime. Very different system than our own planet.
Now, while it is located within the habitable zone, which means that there is potential for liquid water and maybe some life, the fact that Proxima Centauri is an active star releasing about 400 times more X-rays than we get from our star, it's more than likely that this planet is just hanging out in close orbit.
The other way I say it is, if there is life on there, we don't want to mess with it because we can't kill it. It's a better wish than not. But that's exactly right. There's more than just the size and the orbit of the planet. And this is really, we've talked about this a few times now, what all these new discoveries are about is not just pinpointing the size or its orbit, but, what is it, what is its rotation like? What is the host star like? It's measuring the system as a whole. Because as you said, if this planet and one side of the planet in particular, the side with daytime, is just bombarded by radiation constantly, you just can't survive that in any way, shape, or form that we think, right? That we think we can manage. it just becomes completely impossible. It's not to say that it's impossible, but in the way we understand life and evolution, it doesn't seem to be the case. And so it's more of just finding these planets, it's finding the whole system. And that's really what a lot of projects, especially here in Australia, are about: measuring the star and the planet, putting that picture together. Because if you discovered our planet exactly, you know, imagine our planet, but the sun was very different, or we didn't have a sun, you know, or the sun was a red giant or a red dwarf, this life on this planet would be very, 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 very different.
And interestingly, there's some Hubble data from about 25 years ago suggesting that, or helping to suggest that there's the potential for 2 more planets in this system.
That's right. You know, I mean, Proxima Centauri has been imaged a long time because it is the closest star. That is one of the benefits of this planetary system. Even if it's not habitable or anything like that, it's just close. So it's just easy to study. That's the benefit. And as you said, the data from Espresso and Hubble Space Telescope has hinted at maybe 1 or 2 other planets in the system. Again, just showing that it's not just a or one planet around a star, that there's multi-planet systems are almost the norm, that there's a lot of these things going around. And again, these planets have to be confirmed. And what those planets are like are very different, because they tend to be hinting that they're a bit further out, and therefore, you know, the issues relative to Proxima Centauri B would be a bit very different. So it's an interesting time in exoplanets, and it's going to keep going like this for, you know, the next decade. And this is exactly what the whole goal of TESS, the Transiting Exoplanet Survey Satellite, trying to do. Kepler, the new Kepler Space Telescope, is just looking at all the nearby stars to find the planets, because if planets are so common, we don't need to go look, we don't need to try hard. So let's just get the easy picking fruit, because that's the ones we should focus on.
Well, if we can travel at the speed of light, it'll take us 4 years to get there. If we can get a little bit quicker with a Star Trek warp drive, we'll get there a little bit quicker and we can find out exactly what is going on. But I think Brad's right. I think the planet is a little too close to the star to have an advanced alien civilization there for us to make contact with. And I'm still holding out hope for the Vulcans in 40 years. It really seems like World War III is only a few years away, sadly. That's the current world climate, really, isn't it? Well, hopefully that doesn't happen, but something that will happen is Glenn Nagel from the Canberra Deep Space Communication Complex joining me for a chat on Monday about Deep Space 43, their communications dish, the radio telescope down there that's getting a massive makeover. That's happening on Monday's edition of a Trekzone Conversation. And of course, Brad will be back for Talkin Science again Tuesday through Friday next week, and our uncut edition of Talkin Science next Saturday. Well, that's a long time away. Thanks very much for your company. It is time to continue on with Saturday here at Trekzone HQ. It's time for you to have a Friday night or a Saturday morning, wherever you're watching us across social media. Don't forget to like, follow and subscribe to Trekzone, and like and follow Brad on Facebook, Dr. Brad Tucker, and BTucker22 on Twitter. I'm Matt Miller. Thanks so much for watching this Trekzone live stream. It's been a blast. It's always a blast to put something live to air, which is really cool. Like I said, I'll do it again next Saturday. But before then, I'll be back on Monday with my chat with Glenn Nagel from the Canberra Deep Space Communication Complex. I'm trying to speak too quickly. My mouth is working faster than my brain. Alrighty, we're out of here. Live stream over and done for another week. Thanks so much for your company. We'll see you again soon.